Okay, section 3.3, modeling with functions. So our objective. So first objective is to understand function notation. So function notation is how we're reading things. So before we read things like y equals 3x plus 2. Now we're going to read it as f of x equals 3x plus 2. And before we would say, let me make this a little bit clearer. So on the right side, I'll put our new notation. Left side, we have y equals 3x plus 2. So now we would change that y. And instead of saying when x equals 3, I could just say f. And then instead of the x equals 3, I just put 3 right here. And I would write it like that. So that's how our function notation will be changing. And we're going to learn more about it today. I'm just giving you a preview. Evaluate functions given a domain and range. What's your domain? X. What's your range? Y. This is again about just function notation. So instead of saying like y equals 3x plus 2 when x equals 3, x equals 2, x equals 1. This is now find your range. So we're just writing it different. We've done it before. Find your range when your domain is -2, or actually, let me put the same numbers, is 3, 2, 1 for the function. I could just write f of x equals 3x plus 2. This was the old way. This is the new way that we have to write it. So notice the vocab that we're using that won't change, and you have to remember what it is. What's domain, guys? X. And then remember f of x represents your y. So when they're saying to find the range, they're just saying find the y value. Okay, use function notation in terms of a context. So the final part is after we've learned these two checkpoints, we're going to need to know how to use this in an actual application. So maybe if I'm playing basketball and I have 10 points on the board, how many points do I have after let's say 10 shots made that are 2-pointers, 2-point shots. So not 3-point shots. So here we would write it as f of x equals, and then we would say that you're making there's 2-point shots, 2x plus 10. You start at 10, 2x. So we would have to be able to make this equation and be able to read it as a context. So remember, this is your starting point. This is your starting point, and then this here is how many points you make. So this is every shot you make 2 points. So then I would plug in, well, after 10 shots, I would have 2 times 10 plus 10. What's 2 times 10? 20. I started with 10, so 20 plus 10. I would have 30 points after making 10 2-point shots. What you need to be able to read, though, is if I gave you something like f of 12 equals, what is that, 24? What do you think this means? F of 12 equals 34. So over here, when I had the 10, that was that 10 shots are made, right? How many shots are made in this problem? 12. So I need to be able to read that it would be after 12 shots, I have a total of 34 points. So that's what they mean on this last one. Use function notation in terms of a context. You need to be able to read it compared to the application, whatever the scenario is. All right, let's start. Don't get scared. I gave you a little bit more of an introduction than I usually do. But now you're geared towards what we're trying to learn. Okay, function notation. Review what we have learned. What is a function? So a function has one x value for every y value. How do you find out if you have a function given the equation's graph? We said this just last video, vertical line test. Example of an equation, xy notation. Okay, let me give you a second to copy those answers. So those are all review from the class section that we just did, so that's why I went through it a little bit quick. Okay. Now, here's an example of an equation, y equals 2x plus 4. We have our function notation. What is the reason for this change? So we have, before we have xy notation. This is our old notation. So if you want, write down that this is our old notation. And this is the new one we're trying to learn. New notation. If you keep on hearing that word notation, you're like, what does that mean? That's just our way to write things. Notation is our way to write things.
Notes.
So notation in math, it comprises of a lot of symbols and those kind of things. So we change it constantly. You always have a new math notation as you go up. Like when you get to calculus, this is your integral. 3/2. So you have to understand what this math notation is, and so on. All of you guys are going to calculus, right? Yeah, you can do it. That's where math gets fun. Right now, you guys are crawling. This is just learning the basics. All this stuff applies to the calculus. All right, so we have y equals 2x plus 4. Solve y equals 2x plus 4 when x equals 2. So compare from line to line. So here we could have wrote it as f of x equals 2x plus 4. Now we know that the equation is a function. So this f of x part, it tells us also that it's a function. We don't even have to do the vertical line test. It tells us it passes vertical line test. So solve f of 2. So f of 2 is the same as when I say when y equals 2x plus 4, solve for x equals 2. All I have to say here is f of 2, look at what f of x is, and then plug it in. You guys following? All right. Then we plug it in, work it out. You would get 8. You would still get 8. But notice about the answers. This is a big thing. Here, let's start here. Here, the answer, given this answer, I know one thing. The answer is 8. Right, Jacqueline? Yeah, for sure. All right. Given the answer here, I know 3 things. Who brought a duck to class? Who brought a duck? You know to leave your ducks at home. Well, that sounded pretty realistic. All right, so the equation f is a function. Number 2, when the domain is 2, the range is 8. So think about that. When the domain, what does domain mean? X. Yeah, I like the point. Is 2. The range is y. No one was pointing back at me. I thought everyone was going to point at me. Okay, the range is y. Let me scroll down so we can read the third reason. I use the function f of x equals 2x plus 4. So once again, look at the differences based on the answers. This only gives me one set of information. This gives me 3 sets of information. So we know that it's a function. We know that I used my domain and range. Here I only know the range. For the answer is 8, we know the range is 8, is what we could say, instead of the answer is 8. So I know range is 8, and I know domain is 2. And then on this one, I use the function f of x equals 2x plus 4. So I even know what equation I used to get this, because I would look back up here, find out that the equation is f of x. Okay. Evaluate the following functions given the domain -1, 0, 1. Domain, guys, what is it? X. Oh, you're trying to impress Mr. Garcia, huh? Good for you.
It's fun. Look at that.
It is. It is fun. He means it.
Look, everyone looks excited.
Put that help me sign down. Put it down. All right, so you have -1, 0, and 1 here, right? You plug it in, and we would get that when the domain is -1, the range is 2. When the domain is 0, the range is 4. When the domain is 1, the range is 6. So if you look at this whole page, I'm scaffolding your learning on this. So the first one's done exactly how I want you to do it. The second one's missing just a little bit of parts. The third one a little bit more, and then, the second one a little bit more. The third one is missing the whole thing, but I want you to write it the same as you would for the example. Make sense? Kind of? All right. So let's do the first one together. Basically, I take away parts on it to where eventually on number 3, you're going to do the whole thing from just the problem. Okay, number 1, you have f of x equals 3x plus 2. We're finding for the domain -1, 0, 1 on all of these. So I plug in -1. We have 3 times -1 plus 2. What is 3 times -1? -3 plus 2 equals f of -1. F of -1. What is -3 plus 2? -1. Okay. What was the domain for this first one? It was -1. So when the domain is -1, what was the range? -1. So right here. Okay, f of 0 equals 3 times 0 plus 2. What is 3 times 0? 0. Plus 2. What is 0 plus 2? 2. Make sure to write both the left and the right side. F of 0 equals, what's 0 plus 2? You said 2. What's your domain? 0. What's your range? 2. Okay, last one. F of 1 equals, what's 3 times 1? 3. Plus 2? 5. F of 1 equals 5. What's your domain? What's your range? Good job, guys. Okay, now you see where we're going with this? The second one's missing a little bit more, and then the third one you start from the very beginning. So just the problem. Go ahead and work on these next 2 problems. You have about 5 minutes. This takes an input example, x equals 5, processes it, and then gives an output. The input is processed according to an algebraic expression, which is also known as a function rule. So we have this formula here. Now, as function notation, what would it look like? How would I write this over here? So go to your notes if you need help. This is the old notation, new notation.
F of x equals 5. X in parentheses plus 3.
Okay, good. So we could have wrote it like this also. Either one would be fine. Doesn't change that it's multiplication. So he did the parentheses because he knows that he's going to be substituting it in next. What do you think I put in here?
5.
Wait a second. What the?
No.
Oh, there. Okay, sorry guys. Look, there's a typo on this. So instead of... Okay, because this should be a 2 here on all these. So change those to 2's. So those are typos from the book. Yeah. So change those to 2's. If you want, scribble it like this, put a 2 above. It's easier than changing these to 5's on here. So then we have the input is 2. What's 5 times 2? 10. What's 10 plus 3? Genius. All right, what was my input? Remember, my input is domain. My output is my range. So we're finding even more words for input and our domain and range and X and Y. Let's do this real quick. Find an area to write this on. Okay, we started with X and Y. X, another word for X is input. For Y, it would be output. X is domain. Y is range. X is going to be your independent variable. And Y is your dependent variable. Can you think of anything else? So I'm putting all the synonyms with it. Okay, find somewhere, copy this down. It's important that you know when you see one of these words that we're still talking about just X and Y. Okay, copy it down. Did you copy it? Yeah? That's fast. Okay, going to continue in about 10 seconds, so finish up. Okay. Oh, let me scroll back. All right, what was the domain? What was the input for this problem? No yawning. 2. What was the range? No yawning. It's epidemic. 13. What is the function rule? Now this is something new, so I'll tell you. Your function rule is just what operations did you apply to it? So that's the whole problem. You multiplied by 5, and then you added 3. So it would be 5x plus 3. So what changes did you make to it? And it's just whatever is on the right side, basically. You multiply by 5, you added 3. Y equals 25x plus 35. How would I write it as function notation? Good. Okay, now x equals 3. What should I put here? How would you solve it on this one? 25 parentheses plus 35. What do I put in the parentheses? 3. What's 25 times 3? 75. What's 75 plus 35? Oh, take your time. There is a 10, but not 200. There you go. Small mistake. Okay, 110. What should I put here? What goes in here? 3, because that was from the x equals 3 part. All right, so now, does anything change on my work? No, nothing changes. So it's mainly that f of x notation. What's my input? What's my output? 110, and that's the same for left and right side. What is your function rule? What did you apply to it? Good job. All right, let's go on to the next one. Concept check. Does the input depend on the output, or does the output depend on the input? This one is almost like a chicken versus an egg argument. What came first, the chicken or the egg? Because if I give you a range, you're going to say that the range gave you the output, right? Or range gave you the domain. If I give you a domain, you're going to tell me the domain gave you the range. So it really depends on what I give you, right? Think of it this way. Is it, if you're running, is it the time given that gave you how far you ran? Or is it that you ran that gave you the time? What? Okay, good. That was supposed to confuse you. So let's skip this one because I don't like how it's worded. It really isn't an important topic. So it's not going to show up on your test. If it does, we'll talk. But it won't show up. It was worded wrong. Luis, stop staring at me so hard. I'm just kidding. All right. Let's go on to the next one. Justify reasoning. The function f of x equals negative 6x plus 11. This has a range given by negative 37, negative 25, negative 13, and negative 1. Select the domain values of the function from the list 1, 2, 3, 4, 5, 6, 7, 8. Explain how you arrived at your answer. So you're going to make an XY table. All right. Your domain is what, X or Y? X. So this is your domain. This is your range. They gave you range values. So you have negative 37, negative 25, negative 13, no giggling, negative 1. Okay? So if your domain is X, then your range is, what do you think? Nope. Okay. What was another thing we said for Y? Output? No. So what is your range? Y. What was the other thing we said for Y though? It's our notation. No? Not out of the words that we put up there. So it's not in the words. I'm looking for the actual notation. So look at the problem before. What did we see on the problem before? We said we have y equals 5x plus 3, and then we have f of x equals 5x plus 3. So what's another way we could write y? F of x. Okay, that's what I'm looking for. So you have your range is f of x. Reason why I say that is this, instead of y, we're going to start putting, instead of y, it helps if we put f of x. Reason why that helps is when I'm trying to solve for this problem, notice that I don't know what the x is, but I know what the f of x is. So I'm going to take this negative 37. Do you think I'm going to plug it in for the x? No, because it's in the f of x column. So I'm going to plug in negative 37 here. And now solve. Because I'm going backwards. I have this range. I'm going to find the domain. So I'm going to now subtract 11. Subtract 11. What's negative 37 plus negative 11? Negative 48 equals negative 6x. Divide by negative 6. Divide by negative 6. Make sure you're copying this. 8 equals x. Take this 8 Now I'm going to plug it in there. And from this function, or domain values of the function from the list, we got to find on the list. 8 is one of the answers. Okay, I'll set up the next one for you. So next one, negative 25, we're going to plug in negative 25 equals negative 6x plus 11. Okay, it's set up. Go ahead and try to solve for x there and see which one it is on the list, 1 through 7.